Right. We've arrived safely, computer. Could you download a copy of the mission brief for me?
Of course, Captain Buster.
Uh-huh.
Download complete. Humans use electricity to power nearly everything. They use so much electricity they have to get it from a variety of sources, as no one source can supply enough.
Oh, they get electricity from sources, like ketchup. Order some chips, Pong.
No, Buster. Sources as in where it comes from. Sources humans get energy from are natural gas, oil and coal, which are fossil fuels, nuclear power, and renewable energies, which come from the wind, the sun, the sea, and other water sources. Your mission this trip is to investigate nuclear power.
Cancel the chips, Pong. Got it. So, how does nuclear power work?
That's one of the things you're going to be investigating. I've gained you access to a nuclear power station called Hinkley Point, which will help you find out.
Aha! Wow! Come on, Pong. Hinkley Point, here we come.
Not so fast.
Sorry.
Buster, don't be silly. He's a serious man.
I didn't mean slow, I meant stop.
Oh, I see.
Do you be Captain Buster and Lieutenant Pong?
Yes.
We've been expecting you. Poogle booked you in on the next tour. Can I see some identification, please?
There you go.
Well done. At least you remembered your space passports this time.
Thank you.
Thank you.
Now, if you could please put these on.
Oh, bright yellow. Snazzy.
It's a high visibility jacket, and we take safety and security very seriously at Hinkley.
Do you hear that, Buster?
Thank you for your help. Can we go in now?
If you have any electronic equipment on you, you need to hand it in the reception.
Oh, do you mean like this handy micro hair trimmer, yes?
Oh, Buster, that's mine.
Yeah, exactly that.
OK, we'll go and sign them in then. Thank you.
I'm going now, Buster. Be good.
Where do we even begin, Pong?
Hi, you must be our new visitors.
Yes, we're on an important mission to learn about nuclear power. Can you help?
Of course I can. You're on Hinkley Point B nuclear power station, and that's owned by EDF Energy. There are 8 power stations in the UK, and this one started in 1976.
Oh, and how much electricity is made from nuclear power?
That's a really good question. There's 430 power stations in the world, and they produce 13.5% of the required electricity.
13.5.
And 20% in the UK.
20%?
Come with me and we'll see how it all works.
Oh, wow!
That's a nuclear reactor. That's where we generate nuclear power.
Computer, can we have the knowledge file on making power on Earth, please?
Download complete. A power station makes electricity. Fossil fuel power stations, that's coal, oil and gas, and nuclear power stations both use the same steps to make electricity. These are: firstly, fuel produces heat, and heat is used to boil water, which is turned into steam. The steam turns a turbine, and the turbines turn a generator, and the generator makes electricity. Electricity goes to the transformers to produce the correct voltage.
It is like a big kettle, isn't it, Pong? So, how are nuclear power stations different from the others?
The difference between fossil fuel and nuclear power production is how the water is heated. Fossil fuels are gas, oil and coal, and all of these are burned to make the heat to boil the water. Nuclear power stations use the process of splitting uranium atoms to generate heat. This process is called fission. Because no carbon is produced while making electricity, nuclear power is a very low carbon energy source.
So, I've learnt 3 new things already. 1. The difference between how electricity is made from fossil fuels and nuclear is what is used to make the heat. 2. The process used by a nuclear power station is called fission. Sounds like fishing, so I think I'll remember that. And 3. Nuclear power is a very low carbon energy source. Got it. Fee, you! All this stuff is making me feel like a cup of tea and biscuits. But if nuclear power is made by splitting atoms, how can it produce so much energy? Atoms are itsy-bitsy teeny-weeny.
I'll let a nuclear scientist answer that. Jess.
Hi there.
Hi.
I'll see you later in the turbine hall.
Ooh, the turbine hall.
Hi. Did you want to know about atoms?
Oh, yes, please. I think I need to learn a lot more about atoms.
Okay, well, everything in the world is made out of little tiny particles called atoms.
So where do the atoms used to make nuclear power come from? I don't know, Pong. Maybe they do get them online from amaspacon.com.
Here we use a metal called uranium. Uranium is a metal just like any other metal, such as tin, and we can mine it from the ground. Then we can go through lots of different processes and we can make it into little fuel pellets like these.
Ooh.
Have a look.
Wow.
Did you know one pellet can provide as much heat energy as a whole ton of coal?
Computer, how could one pellet of uranium make so much energy?
Well, uranium is normally used as the fuel in a nuclear reactor because their atoms have relatively large nuclei that are easy to split, especially when hit by neutrons, which is what happens in a nuclear reactor. When the uranium atom splits apart, it releases a massive amount of heat energy. The split atom then goes on to split other atoms, creating a chain reaction and more heat energy.
Ah, like that song from the 80s. We like dancing to that in the ship, don't we, Pong?
Concentrate, Busta. Nuclear reactors are designed to both start that reaction and control it to make the heat. That will heat the water to make the steam that turns the turbines, which turns a generator that makes electricity.
Wow. OK, so where do the pellets go?
These pellets go into things called fuel assemblies. Come with me and I'll show you. This is the fuel element. So these pellets that we saw earlier, yeah, we put 64 of these inside one can, and then we put 36 into one element.
Oh, my brain hurts. I think I definitely wish I'd paid more attention in space maths class.
Then we have 8 elements in one fuel assembly. And we have 308 fuel assemblies in each reactor.
Wow.
So that's like 5.7 million of these little pellets in each reactor. Come on, I'll show you. So at the heart of the reactor, we've got a graphite core, which we call the moderator, and some control rods. This is what we use to control the speed of the chain reaction. When the chain reaction is finished, nearly all of the material which could emit radiation is kept safely inside these fuel assemblies.
Isn't radiation bad for people?
We've got really strict procedures in place to make sure everything's completely safe and all the radiation is contained. This is all encased in 5 metres of concrete, which shields from the radiation.
So, once all the heat energy has been made, what happens to it?
We use a gas called carbon dioxide, which we pump around the core. It takes the heat away from the fuel into the boilers. This boils the steam until it's superheated and really high pressure.
Yes, Pong, you are very good at making superheated high-pressure steam too.
I think Pete's ready for you now, Buster.
Oh, hello, Pete.
Hello again, Buster. This is the turbine hall. Inside those turbines are giant blades.
Ooh.
Superheated steam passes through those blades and creates the electricity.
Wow, like giant super-fast fans.
Exactly.
Oh.
Once the steam has used all its energy, it's cooled down and turned back to water.
Ah, but what happens to the water afterwards?
The water passes through water filters and then it can be pumped around the system again. Come with me, I'll show you where the electricity goes from here.
Pong, can you hear the electricity?
Yes, this is where the electricity leaves the nuclear power station. It travels along the wires and goes out onto the grid. So when people in homes, shops and industry need electricity, the grid sends it to them.
That's so clever. Thanks, Pete. We've had an amazing day, haven't we, Pong?
Buster, I have some information for you about the waste produced from making nuclear power. This is important for your mission.
Pong, look. Ship computer has sent a knowledge download. Let's see what this is all about, Pong. I wonder how much waste there is from making nuclear energy. Let's have a look.
Well, if you took all the radioactive waste ever produced in the UK, it would roughly fill the O2 arena. Almost all of the waste, 90%, is called low-level waste. Low-level waste is about 1% radioactive. It's things like used uniforms and protective equipment worn by the people that work in the power station, and things like nuts and bolts and old equipment. These things get compacted, ready for storage. About 7% is intermediate level waste. These are things which have acted as a barrier to radiation. These things need special handling to stop the radiation getting in contact with animals or humans. They are put in stainless steel drums which are filled with cement and then stored.
Sorry, computer, did you say 7%?
Yes, Buster, now stop being so silly. The remaining 3% of waste is high-level waste. This is highly radioactive. The waste is heated until dry, turned into a powder, mixed with crushed glass, melted and poured into stainless steel canisters and sealed, ready for storage.
Gosh, I'm glad that's only 3% of it then. What sort of things are highly radioactive?
Well, the uranium pellets in this nuclear reactor are high-level waste, so highly radioactive. They last about 5 to 8 years and then need to be replaced and safely removed.
Ooh, what happens then?
Once removed, the pellets are kept in cooling ponds for 90 days. Then they're packed into special shielded flasks made of steel which is around 39 centimetres thick and then sent for reprocessing and safe storage.
So where's all the waste kept?
Most are sent for safe storage at nuclear power stations.
I wonder how long it has to be stored for too, Pong.
By current calculations, 97% of waste will become non-hazardous within decades. But the 3% of waste that is high level will stay radioactive for thousands of years and must be stored safely for all of that time.
OK, understood. Well, I must say all that has been very interesting. I think I should be able to earn my nuclear power badge soon, Pong. Let's go and file our report. There you go. Bye-bye.
Good night, sir. Behave yourself.
Come in, computer. Can you hear me?
Yes, Captain Busta. What have you learnt?
We've learnt that nuclear power is a very low carbon energy source. Nuclear power stations are able to make a lot of power, but the waste they create is radioactive. Although nuclear power stations only produce a small amount of waste, 3% of it is highly radioactive and remains so for thousands of years. This waste must be stored very, very carefully. What would happen if there was an earthquake? Or if someone driving a spaceship had accidentally been eating a chocolate bar when they were landing and had driven their spaceship into Hinkley Point Power Station?
Well, Buster, that's a very good question. The containers that house the reactors are built to survive earthquakes, flooding, fire, and even aircrafts falling out of the skies.
Ah, well that's good then, isn't it, Pong?
Buster, every energy source has its advantages and its disadvantages. Burning fossil fuels releases carbon dioxide into the atmosphere, which is one of the causes of climate change. Nuclear energy is low carbon, but creates radioactive waste, and renewable energy like wind, solar, hydro and tidal are also low carbon, but are not available at all times. Right now, no one source is the answer.
So, what's the solution, computer?
Well, the only way to supply the amount of energy that humans use at the moment is through a range of different sources.
Oh, you're right, Pong. If people wasted less energy, less would need to be supplied.
Exactly.
Wow, so they just need to switch off and save it. Computer, beam us back up to the ship. We need to begin our next investigation into renewable energy sources.
Beaming you up now, Buster. But don't forget to get my fur trimmers back first.